Okay, so how are we going to actually compute this derivative? As we always do, limit h approaches 0 of f of x plus h minus f of x over h. Which, how is that going to look in this case? Our function of interest is ln x. So if you take our function and put x plus h in, well, that's going to be ln x plus h minus, put in just x, that's going to be ln x. This is all going to be over h, and this is a limit as h approaches 0. Okay, now to work from here. Next, note upstairs, because I mean, let's just make an observation. At this point, if you plug in h equals 0, you'll get 0 downstairs. Already not going to work. So let's start sort of algebraically manipulating this to try to simplify to where we can get an actual result. And the result that we're going to get is from, like to simplify this, is note upstairs you have two ln's being subtracted. Well, that can be simplified and rewritten simply as, in this case, limit as h approaches 0. You're still going to have h downstairs, but now these two ln's that are being subtracted could be written one over another inside the ln. So we could write that as ln x plus h over over x inside a single parenthesis, exploiting this rule. Okay, so now we've got that out of the way. What can we do now at this point? Well, let's think about this for a second. We've got x plus h over x, right? That's what's inside our ln. Let's simplify that for a second, because x plus h over x, they're both over the common denominator, so you could write this as x over x plus h over x, just breaking down the computation into a pair of terms being added. And when you would do that, you notice that you get x over x, which is just 1. So that's kind of a nice simplification. And if we use that simplification, we can apply it and get limit as h approaches 0 of ln 1 plus h over x. And now I'm going to do something that's maybe a little bit funny, but instead of dividing by h, which is what's in the denominator, I'm just going to multiply by 1 over h, which is, I mean, something you can totally do. Yeah, getting to this point now, all we've got is, well, instead of, again, dividing by h, you're just multiplying by 1 over h. Instead of dividing by 2, multiplying by 1 over 2. Instead of dividing by 5, multiplying by 1 over 5. It's the same process, but now here's what we're going to do at this point. So note, 1 over h is just a number, whatever number that is, and that number is being multiplied by our ln. So, well, if we have a number multiplied by our ln, we could take that number and write it as an exponent. So I'm going to do that. Limit h approaches 0 of ln 1 plus h over x raised to the 1 over h. And now we've gotten to this point. Okay, we've used this fact, and here we are. Now, I'm going to do something that may seem a little bit crazy and strange, but I'm going to sort of like change variables here for a second. And because this thing that's written as h over x, this thing that's h over x, I just want to call that a. And why I want to call that a is because I want what's inside my parentheses to look like 1 plus a. So to use this limit that we computed earlier, I want 1 plus a to be inside my parentheses, so I need h over x to play the role of a. Okay, so that takes this expression, limit h approaches 0, and now we've got ln of 1 plus a. But now, wait, what about this 1 over h? Because you see, 1 over h, I claim we can express that differently given the variable change that we've made here. Note, if h over x equals a, we could multiply both sides by x here, and if you multiply both sides by x, you'd get h equals ax. Just multiply left by x, multiply the right by x, you get the same thing back in return, or at least rather a statement that would still be equal back in return. Equal things times equal things would be equal things. But here we got h equal to ax. So what is 1 over h? Well, 1 over h would be 1 over ax. All right. And now finally, let's think about this limit as h goes to 0. Because as h goes to 0, the numerator here goes to 0, and 0 divided by anything is 0. So instead of thinking of this as h going to 0, you could also just say, well, as h goes to 0, a goes to 0. So if we change the variable to go from h to a, h going to 0, numerator going to 0, that means a goes to 0. So we can rewrite this expression not as a limit of h going to 0, but now as a limit of a going to 0. Okay, and then how are we going to simplify matters from here? Because this expression that we've got is really, really similar to the 1 plus a to the 1 over a that we had previously. You've just got this additional x here, unfortunately. Well, think about this. This is a power, and you know that using your exponent rules, that a power raised to a power multiplies the exponents. So if we take this 1 over ax and rewrite it, one over a raised to the 1 over x, this is going to now, well, no, this is going to be the same thing because, well, it's written in a different form, but when you have 1 over ax, that is just 1 over a times 1 over x. And when you have a power raised to a power, you multiply the exponents, which would get you to the 1 over ax that we have written to the left there. But now, how are we going to simplify this? Utilizing the fact that when an ln is raised to a power, you could bring the power down. We can bring down the power 1 over x and just get ln of 1 plus a to the 1 over a. And this is all a limit as a approaches 0. But now, after all of this work, we finally put ourselves in a position where we can sort of lay the hammer down and deliver this problem completely, because while 1 over x is just 1 over x, because that does not depend on a, the ln 1 plus a to the 1 over a, well, you know what 1 plus a to the 1 over a is. 1 plus a to the 1 over a, as a approaches 0, becomes e. So that inside an ln becomes ln e. And ln e is the very thing that was equal to 1. So this would be 1 over x times 1. Anything times 1 is just itself. The derivative of ln x is 1 over x. And long story short is, all of the computation that we just sort of cumbersomely labored through never has to be done again. But we can see now that the derivative of ln x is 1 over x, and with that in mind, we can attack examples with this in front of us, never having in front of us again what we've just done. All of this behind us with simple computations to follow.